Welcome back, everyone. It is time for the continuation on the Predicta holiday. I'm sorry for using really old footage on you for that first part. I know we didn't do a whole lot of anything, but I needed something quick because I've been busy with other projects that are not electronics related, and I had to sift through some old files and see if I had anything to use. And congratulations, you got the dregs. But I had been working on this TV a little bit in the background, and predominantly on getting the main deflection board here up and running, because I want to be able to get this sorted, put it back in the chassis, see if we get deflection again like I did initially when I tested it, before I move on to the electrolytics, the other random wax caps, and then the IF string. So to bring you up to speed on what I have done, actually, the first thing I did was to clean the whole board, and I tried using soap and water, basically putting it in my slop sink, covering it with Dawn dish soap, and then using a toothbrush to clean everything around, because I'd seen people do that before. Not going to do that again, honestly. I found just using Q-tips and denatured alcohol works just as well. It's more tedious, but it works just as well, and it's what I've been doing to get around some of the funkier shaped components on this. Yeah, it's what I usually use. That works out pretty well. But you can actually see this whole board has been scrubbed. You can see all this discoloration from the heat. This is underneath one of the tube sockets here, and it started to go dark. So these things generate quite a bit of heat. And the traces on the back are pretty delicate. Actually, around the sockets here, removing them has been trying to be very careful because they tear. It's not a whole lot holding those onto this board anymore. Yeah, so cleaning it was the first thing. Then I pulled up the Sam's PhotoFac and I started going through. And I am technically just shotgunning this. Having watched plenty of Bob Anderson's videos on the Predictas, he basically concluded, and I felt the same way, that there's no reason to not just do everything on these boards. Do it once, do it well, and then not have to worry about it. Because if you just go and say, oh, well, there's only one or two resistors that are out of spec, go in, replace them, put it back in, wire wrap everything back in, and then discover that one of them actually has an internal arc, or one of the capacitors, or one of the couplets is bad, or one of the tube sockets is failing because they're a two-piece construction and they suck. Yeah, you can't just pull one of these out like an edge card or something. There's no sockets. It's all wire wrap, so you got to undo everything, unsolder all the ground tabs that hold it to the chassis. It's a lot of work. So doing all of it now, putting all new resistors, all new capacitors, couplets and tube sockets, and just getting it done once, that way I never have to worry about it. That's worth it to me. So to that end, I started on the left side of the chassis. Haven't replaced this disc cap. I'll do that later. That's more of a reference point to my drawing that I made for where all the wires go. And I've been working my way from left to right. I still have the rightmost section to do. You can still see all the carbon comp resistors. This capacitor, going to replace that because I don't like the whole stub lead things. Still got a Black Beauty sitting right here, and this couplet needs to go. In fact, this couplet appears to be a replacement because it has been soldered to the stumps of the previous one, and I believe it is it's a standard Philco part. Now, as far as the replacement couplets go, one method is you can just cut little pieces of perforated board and make your own, make some wire leads, because the PhotoFacs show all the component values. So that's not impossible to do. Plenty of people have done it. But there's a gentleman on the internet, this gentleman, TV Restorer guy, that does nothing but make and sell reproduction couplets for all Predictas. All you need is the run of your chassis, or the particular board that you're working on. Go online, and for 50 bucks you can get a full set of the ones specific to your set. And he's got a breakdown of all the couplet numbers that are included with each kit. So if you don't know the run number, which is indicated by a blob of paint up here on the top left, mine is white. This is actually a run 1 chassis, so this is the first iteration of this board. Apparently not that common. He had to double check with me to make sure that that was correct. Although it does specifically say this is for chassis 9L37 Run 1 and Run 2. So those are, I guess, less common than some of the later ones that have like yellow or red paint. I can't remember what the other colors are. Either way, the two boards are going to be marked. However, the IF board, at least on the 9L37, does not have any couplets on it. At least not on mine. So I've only got this guy here to do. I want to say that one of these actually winds up underneath the chassis. I looked down in there a little while ago. The one that I don't know is this round guy here. Haven't found this one. This might be something only for Run 2. That's just included to cover that. Either way, for 50 bucks, they fit exactly in there. They are labeled. Wire loops are labeled. They look great. So highly recommend that. And then the other thing that I am doing, again mostly on Bob Anderson's recommendation, is I'm replacing all the tube sockets on this. Normally I wouldn't do that, but in this case he brought up the fact that these are actually a wear component and a failure point in the design. And if we take a look at one of these, here's Philco's sockets. Here is a more typical PC mount tube socket. You can see that the contacts on this go straight through the bottom and have sort of a pinch assembly to grab a hold of the pin. So when you insert the pin, it just spreads apart and grabs a hold of it. That's pretty typical. These, on the other hand, are a two-piece construction. So the pins that go into the circuit board are on the outside, and the inner circle here, the inner, come on, focus. The inner row is where the tube actually seats. And what's unusual is that the pin goes up into here, clicks in place, and then it has a bent wire tab that comes up, over, and then bends down into these inner recesses. And those inner recesses have a small C-shaped piece that drops in from the top, and this bent tab goes over it and locks it in place. And when the tube is inserted, this bent over piece is sort of pressed to the back of that little insert, and that's what creates the contact. And I could definitely see oxidation forming between those two components and making it so that you get really bad contact. And no amount of cleaning is going to allow you to get behind or in between that little round piece and this bent over finger. Honestly, it's a very cheap design. This one I managed to get out intact. This is actually from the upper row. I have already replaced all three of these. I actually had these in a bin of tube sockets that I went through. So I desoldered those, popped them out, got them inserted, soldered them in place. Not too bad. I had to be gentle with them. Getting these out is being much less fun. Even after desoldering them, it was difficult trying to push them out. In fact, for this first one, I had to resort to violence. I just went through with my flush cutters, and I went around the periphery, and I just clipped off. Okay, take two. My camera had a seizure for some reason. Display started going bananas, and it chopped off my video partway through. Anyway, what I was saying was getting this socket out over here was a little more difficult than the others. I wound up having to clip off the pins on the bottom in order to free it, and then I pushed the pins out through the backside of the circuit board. And I definitely recommend that. When you're replacing components on these, or any vintage circuit board for that matter, always extract the pins from the front. If you clip off anything, don't push them down through the top towards the traces. The traces on these will peel off. If you've applied enough heat, or even not even enough heat, they'll just peel right off. There's not a whole lot holding them on there. In fact, around some of these, I've got damage where there are pieces missing, because in the removal process, they just tore like paper. So you want to be very gentle with them. So once they're clipped off, I just gently use my soldering iron to poke the last remaining bit out the back. But I do desolder them first, and I have desoldered this one just to get rid of most of the impediment to it. I'm also going to have to desolder the center post. I'm not entirely sure what this is for. None of these sockets are actually grounded for shielding, but this one has a grounded center post, which is odd. Really don't know what that's for. Sadly, though, none of my replacement sockets have that. Some of my littler 7-pin ones did. I'm not going to worry about it because these are not shielded anyway. So all of these are just getting replaced with these little guys, and they will drop in like so. Just like that. The whole spacing between the two is exactly the same. I'm guessing there was some sort of standard, and then it's just a matter of applying solder and getting the tack in there. Not too bad. And also they take up a little less space on the circuit board, which is kind of nice, and they'll probably be a little bit more resistant to heat. But that's where we're at. I'm going to get the remaining 3 of these sockets dealt with, get cleaned underneath them, then we'll move over here and continue replacing the last few capacitors and this couplet. Once that's all done, we'll move it back over to the chassis, see about getting everything tied back in, and then giving it a test run to verify that I didn't royally screw something up. Okay, I am 3/4 of the way done with putting in the lower tube sockets. Those guys went pretty smoothly. For this last one, though, I did want to show what it takes to get one of these out in a reasonable amount of time. I've already removed the couplet that was sitting down here. These are the solder stumps from the old one that it was attached to, and I'll pull those out afterward and put the new guy in. But if you don't feel like going through the slow process of desoldering the back and then trying to clip each pin, especially since you can't get around there, thanks to the excessive amount of heat that these sockets had to endure, they actually come apart very easily. So the simplest method of eliminating them is to simply destroy them. Because at this point they are basically made of graham cracker. They're pretty brittle. It's another good reason to get rid of them. So the last few of these I have literally just been busting up, and then when I put the soldering iron tip to the bottom of the pin, I can simply give it a little push and they come right out the front. This may seem a bit barbaric, but I just need this to get done. I'm sure you could use pliers or something, but these are the smallest things I have that I could reasonably get in and underneath here. Also, I might recommend eye protection, because these little flying pieces of plastic probably don't feel pretty good in your corneas. But now I've got the outer ring dealt with, so it's just the center holding it together, which means I could even clip these pins off here if I wanted to. We could do that. Go like this and cut that top bar that folds over to the middle there to release all of these. I think I got all of them. Didn't I get all of them? Come on. Nope, still holding on by one. There we go. Alright, so that's the remnants of it, and then all I gotta do, so we can flip that over now. And I'm using a very wide and flat soldering iron tip for this to get a decent amount of heat in there. Should be able to soften one of these and then just pop it right out. There we go, that's all of them. Not too bad. And then all we have to do afterwards is clean up the stuff that was trapped underneath the surface here. A little bit of denatured alcohol. Obviously, as I come out here and I start replacing the resistors and the remaining capacitors, I'll be scrubbing underneath every one of them, as well as around the base of the old couplet. So this definitely helps the appearance some. Yeah, so that's better. And then the new sockets, just a line for that spacing, and that's all there is to it. Drops right in, solder from the back, and you're done. Which I'm going to go do that now, get the new couplet installed, and then continue my way marching across the right side until all the old resistors and caps are swapped out. Okay, I have finalized the replacement of the resistors on here. I got the 15 mega ohm half watt I needed, and a suspiciously small 2 watt 1.5 kilo ohm resistor. It's a Vichy manufactured one. If they say it can take 2 watts, I'll believe them. They make good stuff, but I don't know. Tried to make sure I got all full-size body resistors. And let me get this tucked back in here as carefully as I can. I desoldered all of the lugs on the chassis to make installation less of a bear. At least I'm assuming it will be. So those all just kind of drop down into place like that. Make sure all our wires are free to move around. And yeah, we can see that they're all just kind of sitting right where they need to be. Yep. Okay, so we've got the Predicta set up, reconnected with the chassis. I've got the board wired back in to the best of my ability. I had to burnish all the contacts before I could really get them hooked up properly. And I had to go back and double check where the video signal and the cathode connection for the picture tube comes off this extra point. This is test point C on the SAMs. And then the audio connections go to the green and black wires here. I'm pretty sure it's, yeah, this green and black wire there. These have to slip on over the top, so when I put the wires on, I had to shove them down further to make space. And I also made a new wire for the grid cap for the 12DQ6 here, because it was, actually it was cracking, it had hardened, it was chipping off, and I was able to take the inside of the grid cap apart, solder a new wire to it, and clean it up. And then I popped all the tubes back in. So let's see if it does anything. What I don't know, though, is if the power switch is in the on or off position, because there's, well, no good way to tell. So we're just going to turn that off and see if I get filament glow. Oh. Alright, hang on. We're going to slow that down. I need to reposition the camera, because as much as I love listening to that siren song from the flyback, I don't want to leave it on for very long. We're at 90. And there we go. We're getting a raster, and it's not great. So whatever that wonderful noise is being caused by is causing it to freak out. So we're going to call that good. Alright. Success. Well, we're going to call it successful enough for now anyway. Okay, so that power up went pretty good. We got a raster. Actually a better raster than the first time I tried it. Just take my word for it. Next phase then is going to be going underneath the chassis and dealing with a variety of components down there that need to be swapped out. I think there's also another couplet hiding under there. But I want to start tackling the electrolytics now that I know that most of what's in here is at least doing its job. We've got vertical and horizontal, and it's decently sized. Obviously, I'll have to go through and adjust things to get it right. But I can imagine there's probably some components over in the flyback circuit that aren't super up to snuff anymore. It obviously does not sound very happy. Frankly, I've never heard of a flyback transformer make that kind of noise before, and if you saw from the way that the picture was flickering to the tune of that thing, something is either, I don't know, arcing or leaking intermittently like that. Pretty good. So, I mean, it doesn't help that I don't have it shielded. There's supposed to be a sardine can over it, for crying out loud, but I didn't feel like putting that back on. But that being said, it's working. Obviously, we know the CRT is functional. It means that all the crap that I put into this has not affected the operation of that board. The only thing I do not know is if I feed it in a video signal, if we would even get anything. That would require going through the IF stage, and I haven't done that yet. There's really only resistors in there, and I don't know. Well, maybe we could. Actually, no, because I can't get to the channel knob. I don't. Frankly, I don't want to try injecting a signal yet until I've dealt with the power supply. I don't want to leave this on long enough to try injecting a signal with how this is behaving. I don't know whether I'm damaging it by allowing it to go that long. So we're going to get it flipped over. We're going to go through the underside there and replace the remaining wax capacitors that are in it. Do a little cleanup work, and then we'll check to see if that eliminated the freak out that it's having. Because I want to make sure I pin that down. I know it was doing something similar to that when I started. I don't remember if it was quite that obnoxious, but I definitely had some sort of intermittent noise being made the first time I brought it up. And I don't think I brought it up quite to 100 volts like I did there. So, I think that's going to do it for this one. It's just going to cover getting this board finished up. And I gotta say, the new sockets on here, they hold these tubes really nice. Like, this nice and snug. I was really happy going to those. They worked out superbly. The new couplets I got from the TV restorer guy, fabulous. All seem to be working the way they ought to. And it also seems to mean that all my wiring that I've soldered in here is back where it ought to be. Again, this is why we take good notes. Highly suggest mapping out where all the wires go and cleaning them. One of the big things, a lot of these are covered junk. Use some alcohol, get the junk off of them, make it so that you can tell where they are, and take photos. I took shots of every side of this to make sure I knew where everything went, in addition to the paper drawing. And I also made notes on the drawing if there was something different about the wire, like this is a cloth connection, made sure to point that out, or, marking where out of the chassis each wire is coming so you have an idea of where each yellow wire is, or vice versa. Taking good notes is super handy in that regard. But that's going to do it for this. The next one, again, we're going to flip the chassis over, do some underside work, and then try it again. But until then, thanks for watching.